the last video, we covered some characteristics about the circuits, which are voltage and current. In this lesson, we will try to explain and we'll try to found a relationship between voltage and current. So for example, if you have a pipe that narrows at a certain point, and you have a flow through it, if it is a steady flow, you can say that the flow over here will be the same over here, right? But because of that, the pressure in this side will be a higher pressure than in this part, causing the flow to go in this direction, right? This can be translated into circuits, which is called a resistance. And this component we call resistor. And it has a characteristic which is his or her, I don't know if a resistor is male or female, his resistance, right? Which is measured in ohms. And we write the expression V, it's equal to the resistance times the current. And for the majority of the components of a circuit, you will see that there is a function of the voltage depending on the current, or the inverse, right? The current depending on the voltage. The more common one, it's actually the current depending on the voltage, right? So if we write this, we will have something like this, right? And if we draw a graph, sorry, you can see that we put here the current, here the voltage. For the same resistance, you can see that if we increase the voltage across the resistor, the current will also increase, right? Or if we increase the current, the voltage will also increase, right? So we'll have something like this. And the slope of this relation will be the inverse of the resistance, right? And the inverse of ohm, which is the unity of the resistor, it's called the Siemens. So R, it's measured in ohm, and 1 over R, it's measured in Siemens. There are some older books which represent the admittance, which is the inverse of the resistance, as an ohm flipped upside down. But the correct way to measure the inverse of the resistor is by to use the Siemens, right? So with this, we can start to analyze our first circuit. Let's see, if we put a 9 volts battery in series with a resistor, in the next lessons we'll talk about what means placing it in series or in parallel. In fact, in this case, it is at the same time in series and in parallel. So here we have 0 volts, right? And if you have watched the previous lesson, you know that in this point you will have 9 volts, right? So here is also ground, so here we have 0 volts. So the voltage across the resistor, V, will be 9 volts minus 0 volts. Right? Let's say this is a 1 kilo ohm resistor. So the voltage will be the resistance times the current, right? So the current will be the voltage over the resistance, which will be 9 volts, because this goes to 9, divided by 1 kilo ohm, which will give us 9 times 10 to the power of negative 3 amps, or because we don't like to write times 10 to the power of negative 3, 9 milliamps. And this is typically the values that you will encounter in electronics. So voltages are in volts, resistors are in kilo ohms or mega ohms, and currents in milliamperes or microamperes, not the whole ampere. A whole ampere, it's lots of current. So this way you can see that you can calculate the current across a resistor. If you put, just to complement what we have studied in the previous lesson, if we put a 9 milliamp current source in series with 1K resistor, it doesn't matter the voltage across across the resistor, because we know that the current in this loop will always be 9 milliamps, right? So we can say that the voltage across the resistor will be R times the current going through the resistor. So it will be 1K ohms times 9 milliamps. So the voltage, the K simplifies with the milli, and ohms times ampere is volts. So I have 9 volts. This way you can calculate the voltage drop across this resistor. Right? So we are starting very slow on these topics for you to understand them by the basics, right? In the next lessons, you'll learn about putting components in series and in parallel, the characteristics of the connection in series and the connection in parallel, and so on, right? Then you will learn how to simplify resistor circuits. So hope you guys enjoyed, and feel free to comment down below. And this whole series will be on my website, which you can access by clicking in the link in the description.